What are permitting steps we need to follow to install a CHP plant in the USA?
Well, the basic steps in getting an air permit is first to define the project, and after you've defined the project, you put an air permit application together. Then after the application, you submit that to the agency, review that with the agency until you have a final permit. So those are the basic 3 steps.
What's unique about combined heat and power in this process?
Well, combined heat and power is really great to do permitting. It's a shorter process because the plant is going to be smaller. The plant is going to be burning gas. The plant's going to be more efficient. And the plant's usually going to replace coal. Those are all things the agency really wants to see. So everything is pointed in a positive direction. So what's unique is with those lower emissions, it's easier to put an application together and it's easier to get an air permit. And the agency is on your side. That's what you want. So that's really what's unique about a CHP plant.
What are the keys to have a successful permitting process?
The keys to a successful permitting process. There are several. One is having an understanding of the process you're trying to permit. I've always thought it's great to have engineers do the air permitting because we understand the process that is being tried, you're trying to permit, and you know what flexibility that the owner needs to have. You understand the process. That's a key to success there. The other is a lot of communication. And by communication, I mean the communication between all the parties involved. That would be communication between the permitting people, the owner, the design engineer, the architect if they're involved, the lawyers if they're involved, and also the air agency. The more communication there is, the better off you are. And I think the third thing is having a lot of good strategy. The strategy comes into trying to get an air permit that presents as much flexibility for the owner as possible. And that's another unique thing about combined heat and power is that these are at facilities like universities and industry and district energy where they have to be operating all the time. So they have to have a lot of flexibility, very low load, very high load, everything in between, but they really can't shut down. And whereas a traditional utility power plant, they're just on or they're off. There usually isn't the flexibility. They can plan outages and things. So that's really unique about combined heat and power because of where they're being put in.
Could you give us an example of a real case?
A real case, that's a good question because we're in the middle of permitting a real combined heat and power plant. This is for the Brigham Young University in Provo, Utah. We're responsible for doing all the air permitting for that project. This combined heat and power is replacing 3 coal-fired stoker units, which are being taken out and being replaced the capacity with combined heat and power. And that's going to be a single combustion turbine, and there'll be a heat recovery unit that'll have duct firing on it and going through SCR and oxidation catalyst, so nice low emissions. And so that's the process, that's the project that we're permitting.
How the permitting process is going in this project?
Yeah, I think it's going very well. We submitted the permit application in August of 2016, and we're waiting for draft permit conditions. The really unique thing about this is when you walk into the air agency in the state of Utah, and we told them that they're replacing coal and putting in gas for combined heat and power, they want to issue the permit immediately because that's what they want. And so that's the position that you want to be in. So it turned out that we were really helping the agency write a permit for us. So that was a really good position to be in. So you get into a lot of unique things. The point of this is you get into a lot of unique things about a CHP because they're usually retrofit projects. They are not greenfield, they're retrofit projects, so you have to fit them into a smaller space, fit it into the existing equipment, and fit it into the existing campus demand. And so you just have to be flexible.
What are the biggest takeaways from this best practice?
Takeaways. The first takeaway I would say is communication. The communication is extremely important in doing good air permitting. And the communication needs to involve the permitting people, the owner, the design engineer, the architect, the agency, and even if there's lawyers involved. The more communication there is, the better. That's the biggest takeaway. The second takeaway would be having a good engineer that's actually doing the permitting so you understand the process. It's best to permit something that you understand the process instead of permitting something that you don't understand.